All right, so for this lesson, we're going to go ahead and talk about regressions and inverses. Because remember, the inverse of a square root function is a quadratic. I'm going to talk to you about that real quick here, because when we talked about inverses back in the first unit, whenever we have an inverse of a, it's a reflection over y equals x. So here would be not yx, but y equals x. And whenever we have a reflection of an inverse, say if it's a circle, which would not be a function, by the way, but if it was a reflection over the x-axis, the function would end up being over here. Also, think about it like this. If you have a point, let's say 1, 5. Okay, so we have 1, 5 going on here, and we wanted the inverse of that function. The inverse of that function is when we would switch x and y. So when x and y would switch, that would just end up being our inverse the point was 1, 5. Now we have to switch x and y, and it would just be 5, 1. So if I plot that on the graph, it would be 1, 2, 3, 4, 5, and then up 1. Okay, and that would be a direct reflection over y equals x. And we're going to talk about that relationship between a quadratic equation and the square root. So if we had the parent function of a quadratic equation and the parent function of a square root, this would just be the positive square root, y equals x, and this would be y equals x squared. You'll notice that we are only looking at the positive square root side. There is, however, in fact, a negative square root side. I'm going to delete these points here. At y equals negative square root x that we're not going to dive into. And the reason being is it does not pass the vertical line test in doing so. So what we're going to look at is needing to restrict the original domain or range in order for us to only end up with this y equals positive square root x. Okay, and that's what we're going to start with. Okay, so like always, paper notebook is awesome. Hope you have it. Okay, and we're going to go ahead and run a quadratic regression on Desmos. That's going to come up later in the lesson and determine its inverse. Because the inverse of a quadratic is going to give you that square root function, and they're inverses of each other. But Desmos doesn't have a regression for square root. Okay, so moving on. Here we go. Let's review and find the inverse of a function. So I'll do one with you, but then I'm going to expect you to do 2, 3, and 4 on your own, and then review the answers afterwards. So just pause the video after one. I'll remind you. Now, remember the first step to algebraically finding an inverse is to go ahead and switch x and y. So that's going to be our very first step here. Just rewriting the equation and switching x and y. Now, all of our equations are y equals. We need to go ahead and solve for this inverse. And so we need to isolate y, but it's inside this radical. And the way that we're going to get rid of it, remember just to cube it, because the cube and the cube root are simplifying, and we're left with y minus 7 equals x to the third. Add 7 to the other side. I'm also going to move this y equals, because I know it's going to be isolated at this point, through the reflection property. I can go ahead and move it to the other side. So that's just going to end up being x to the third minus 7. And that's going to be my quadratic or cubic function in this case. Now remember, a cubic function is also going to be the inverse of a cube root. Okay, so that would be an inverse. What I'd like you to do now is you're going to pause the video and do 2, 3, and 4. And I'm going to show the math. I'm not going to explain it for the sake of a shorter video. And you can pause it as long as you need it in order to get those inverses. I noticed once I paused the video that I did have a little bit of a typo here, because when you need to add the 7 over to the other side, So when you add the 7, this should have been also plus 7. So it should have been the inverse of f of x equals x squared plus 7. All right, now please pause the video and wait to see if once everybody's finished checking their work for 2, 3, and 4, and if anybody has any questions. All right, I'm going to go ahead and move to the next slide. Hopefully you had enough time. Please make sure if you didn't to go back to the other and look at each problem and work it out. So now we're going to look at finding the inverse and restricting the domain and range so that the inverse is a function. Because at this time, if we take an entire quadratic and we take the inverse of both sides of the quadratic, then it would not be a function. So if we're given the equation y equals x squared plus 1, that is a quadratic. And we can go ahead and graph that. Remember, the shift is only going to be 1 up, 1 unit up. Okay, and if I do pick a few different points as far as 0, plug that in, that would just be 1. If I try 1 squared plus 1 is going to give us 2, so 1, 2. Another point, let's go ahead and go with 4. Maybe not 4, because 4 squared is going to give us 16, and that's going to be off the graph. So let's go ahead and go with 2. So if we have 2 squared, that would give us 4. 4 plus 1 is going to give us 5. Okay, so that's the positive side of this quadratic, and we also have the negative side of this quadratic, because remember, the points are going to end up being symmetrical to the other side of the first part. So when we find this inverse algebraically, what we're going to end up doing is, because if we're doing it algebraically, we're going to, I'm just going to rewrite the original equation, the quadratic equation. If I find the inverse algebraically, it would end up being a square root equation. So the way that we would do that, switch x and y first. Now we're going to go ahead and subtract x to both sides. And because we have y squared, we're going to square root both sides. The square root of y squared is just going to become y equals the square root of x minus 1. Now do remember that this is the inverse of x, which is the inverse of our quadratic. And remember the parameter changes on the inside are going to shift it right 1 unit. So if we were to shift 1 unit right, we would start here, and the inverse of the quadratic is going to end up being a square root. Now notice how we do not have any graphs below, and that's because we are only focusing on the positive graph. Okay, now step 4. Now that we have graphed, you can see that the graph to write appropriate domain and range restrictions for the original quadratic so that the inverse is a function. When we're looking at the original quadratic, that's this one right here. And our square root is right here. We do not want this side at all. So if we don't want that side to be reflected about the y equals x axis, we need to go ahead and restrict the original quadratic so that we only receive this side reflecting across the y equals x axis. So we do not want that side. So in order to get from here all the way up, we're going to restrict our domain. Okay, we only want from 0, or we can start off and we can write it 2 ways. We can say x values everything except for everything above 0, because we can go from 0 and on, and that would give us all of those values on the quadratic that we're looking for. Another way to write that is 0 less than or equal to x less than infinity. So you can write it 2 different ways. Now for the range, Remember, the range is the y values, and the domain is x values, because it's been a while since we've seen those. For the range, I don't really specifically need to restrict the range, because if I start off from 0 to positive infinity, that's what this would look like. So it would be y is greater than 0. Y is greater than or equal to 0. But even if I restricted the range, the other side of the quadratic would still go. So for the range, you can just say that the range does not need to be restricted. It's only really going to need to be restricted for the domain. All right. So let's go ahead and take a look at some example problems. For this one, I want you to try it on your own first. Okay, and I'm going to go ahead and pause it, and that way you can go ahead and work this one out on your own. Determine what the domain and the range of the quadratic would have to be in order for the inverse to be for it to be a function. The graph is there for your convenience if you choose to use it. Okay, so for this one, I'm going to start off by just picking a few points. I'm going to solve it a little differently than the last one. Okay, looking at the quadratic equation, I do know some information about it it's going to have a parameter change, and the plus 3 is going to have it shift left 3 on the graph. So we're going to go ahead and 1, 2, 3, and that would be the vertex of that parabola, and it is opening up. Whoops, wasn't staring at my screen there. Okay. And we need to solve for the inverse, determine what domain and range restriction we need in order for the inverse to be a function. Remember, the inverse is going to be your square root. So what I can do for this one is I need to figure out, okay, I have 0 for I have for the vertex is going to be -3, 0, that's my vertex. I know that for a fact. So for my inverse, remember we talked about this in the very first slide, if we were just using points and it was the inverse of that equation, which would be the square root, okay, that would actually be 0, -3. So that would start us off, should have put this in blue, as 0, -3, because that would be a direct reflection over the y equals x axis. So we would have 0, -3. Now I could pick another point for this equation to go ahead and substitute in, and another good point to pick is probably going to be 0. So if we substitute 0 and we substitute that in, we would end up with 0 plus 3 squared, which would just end up being 3 squared, which is 9. Doesn't really fit on my graph though, so that would be 0 all the way up to 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so it would continue to go up. So if I were to reflect that, or take the inverse, that would just be 9, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 0. And that would be blue. So that graph is going to continue to go out that direction. Now, since we only need the positive, we can kind of stop right there because we don't want this side. If I have to restrict my domain, restriction, would be x has to be greater than or equal to -3, because I want from -3 onward for that to reflect to become this square root equation, which allows me to have that as an inverse. And for range, no restriction needed. All right, So that's going to be that graph, and you really were only asked for the restrictions for this one. Okay, so let's go ahead and take a look at regression and inverse notes. Now when we're running a regression, remember we can do that on Desmos. Normally we would be using TI Inspires. So if you need help as far as the steps for how to run a regression on your master slide, go ahead and click this TV, because it'll send you to a link that'll allow you to see kind of a short video, less than 5 minutes, on how to do a regression. I'm going to show you real quick, but I'm not going to go through every single step because we've done this before. The one thing you do need to remember is the standard form regression equation. So what you would type into Desmos is going to end up being y sub 1, because we're looking at the y value, the first y value. And this is approximately, so approximate. So you're telling the Desmos computer, hey, can you approximate this for me? And this is going to be ax, and we're still talking about the first point, but remember it's standard form, so that's ax squared. But Desmos likes to know x and y. You're talking about x1, x2, x3, which point are you talking about? Because later on you could have multiple points. All right, so this is the equation that you're going to need to type into Desmos in order to receive your regression. Now, Desmos only does quadratics. So your calculator is not going to do irrational, rational, or root regressions. So you have to use the knowledge of inverses. So what we can do is, because this is a square root equation, we know that we can go ahead and take the inverses of these points, change x and y, switch x and y, and then that would become a quadratic. So once we know that that becomes a quadratic equation, we can actually run a quadratic regression, and that'll give us the equation, and then algebraically what we're going to end up doing is find the inverse of that, which would give us right back to where we started with a square root equation. So that's ultimately what we're doing on this page. Okay, hope you don't get lost. If you do, rewind, and let's go ahead and start with the first step. First step. Now, if we have a square root going to a quadratic, that is an inverse function, and if we are inversing those values, all the x values have now become y values, all the y values have now become x values. So this would be 6, 0, 7, 1, 8, 4, 9, 9, and 10, 16. What we're going to do now is we're going to go ahead and put this table into Desmos. Then we're going to go ahead and tell it, hey, can you please run that regression for me? And it'll run the regression. It'll tell you A, B, and C. And we're going to substitute it back into the standard form of equation for a quadratic. So that's what we're going to do real quick. I already had Desmos pulled up. Please go ahead and do that on your own. Let's see if I can split screen this. Sweet. That way we can go ahead and add a table. So you're going to go to the plus sign, add table, and we're going to go ahead and insert those numbers. Here we go. We have 0, 6, 1, 7. Notice how on the graph they're starting to upload, and I got sidetracked here. We actually need the quadratic, not the square root one. So this is actually going to end up switch. This is 6, 0, 7, 1, 8, 4, 9, 9, 10, 16. Okay, so our next thing is I need to silence that. Okay, so for number 2, what we're going to put in is we're going to put in our standard form of an equation, but that way the Desmos can run that regression for you. So that's just going to be y sub 1, and then approximate, so that's the key next to the number 1, so shift and then that tilde, which will approximate for you. AX1 So we're talking about, notice how on your Desmos, it labeled this column as x1, y1. So it's referring to those points. Squared plus bx1 plus c. All right, now we are given the information 1, -12, and 36. That's going to give us our perfect square, or equation for this question. And we're going to go ahead and write that over here. Whoops. So we have 1, -12, 36. All right. (1, -12, 36. Also, leave that Desmos up. You're going to use it for the next problem. If you don't erase the equation and you just change the values in the table, it will actually recalculate it, so you don't have to type in that equation again, which is pretty cool. So what you're going to do now is we need to write it in our standard form. So that's going to be y equals 1x squared plus, or not plus, minus 12x plus 36. Hey, notice how it's a perfect square. It should be a perfect square, always, okay? Now, what we need to do now, because we have to find the inverse, is we need to go ahead and make a life so much easier, because remember we have to solve for one of these variables. So it needs to be factored. So that's going to be your next step, to factor it. And these steps are written above. So when we factor this one, notice how our perfect square is 36. So this is, and we need two factors that'll multiply to give us -12, but because it's negative, know that it's both of them are going to be negative. They are always going to be perfect squares, so it's going to always be y equals your binomial squared. Okay, now the reason why we have to find the inverse of this quadratic is because ultimately we want to end up finding the equation for these numbers. But the whole point of it is our calculator couldn't do a square root regression. We had to do a quadratic regression. So next we're going to go ahead and find the inverse. And this is going to be our square root equation. So the first step is to switch x and y. So that would end up being x equals y minus 6 squared. And we're going to go ahead and next step to solve for y is to go ahead and square root both sides. We would left with the square root of x equals y minus 6. We're going to add the 6 to the other side. So we're left with the square root of x plus 6 equals y. And that's our square root equation. Square root of x plus 6 y equals. There we go. All right. If you have any questions, please go to tutoring. Miss Young can help you out, or a tutor can help you out. Okay. Next, we're going to go ahead and try this on our own. So go ahead and do that. If you have your information already in Desmos, just go ahead and change the table. But remember, if we start off with f of x, we're going to end up having the inverse, because they tell us that this is a square root function. So this right here is our square root. We need to convert it to a quadratic. And when we do that, we're just going to switch x and y. So that's the first step. I'd love for you to go ahead and pause this video, try this out on your own, and then we'll come back. Okay, I hope you paused it, tried it out on your own, you have your standard form of equation, and then you found the square root. Okay. So I am assuming you have done that. Okay, you're going to switch x and y. I'm actually going to pause the video and fill everything in, and then you're going to go ahead and we'll do the Desmos together. Okay, like I said before, if you leave the last graph up, you would be able to see that you can just change the values in the table and it'll be changing it for you while you're doing it. So I'm going to do that real quick. The y values are the same, so you can actually just go ahead and arrow down and it'll go straight down. So I have -3, -2, and I goofed. There we go. All right. So with the brand new regression that has been run, the parameters are a equals 1, a equals 8, and a equals 16. I noticed on an assignment some of you guys just left it as a equals 1, 8, 16. You do need to write the equation. Otherwise, you're not going to get the second step here. Okay, so over here, I'm going to go ahead and write down, and that's going to be for the quadratic. The inverse of f of x, because remember we found the inverse by switching x and y, is going to be x squared plus 8x plus 16. Okay, now we're not done yet because this is the quadratic equation. They want us to go ahead and find what is the square root to formulate the square root function. So we need to actually take the inverse and go back to find the square root. So what we're going to do is we're going to go ahead and factor this so that we can switch x and y. And so the inverse of f of x is going to end up just giving us x minus 4 squared, or plus 4 squared, because remember it is a perfect square trinomial. Next step, to go back, we're going to go ahead and switch x and y. And this is the process to go ahead and solve for your square root equation. Okay, so we need to square root both sides. We're left with y plus 4 equals the square root of x. And if I subtract 4 over to the other side, I'm going to rewrite y over here. And there we go. So that is our square root equation. Move that back over here, and we're done. Whoop. All right, so that's how you would run a regression on the computer in order to find, or on the calculator to find your square root equation. Any questions on that, you can definitely go to tutoring and Miss Young or somebody will help you out. Okay, other than that, please pause the video anywhere you need it. Go back, rewatch it on your own. Remember that you need to keep up with your assignments and try not to do them late. All right. Have a great day, and I'll see you at some point.